Hello, intermediate algebra students. This is a video for lesson 7.1, which is talking about how to combine like terms to simplify a polynomial. This video is heavy with vocabulary and just some basic naming strategies for polynomials. So bear with me as we get through some of the dry concepts, but it actually is a really important lesson because you absolutely have to be able to add and subtract and combine like terms in this chapter that we're starting today. With a reminder, you can always pause, rewind, and re-watch parts of this video if I go too fast. So our first question, and I have all these notes written in Cornell style, but you should be writing these in your notebook. The first question that I want you to write down is, what is a polynomial? This is our first definition that you need to know. A polynomial is the sum of monomials, which are sometimes called terms. Monomials is another word which you will hear again, and we'll define that in a little bit. Sum is a word that you should know. This means addition. So it's a bunch of terms added together. Polynomials must have whole number exponents. So a whole number exponent, as a reminder, is like 1, 2, 3, or 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically, they cannot have negative or fraction exponents. So when we look at these two examples, 2x squared plus 1/2 x minus 5 and 5y minus y to the 1/2 plus y to the negative third, it's, I think, pretty apparent to see that this polynomial has a negative 3 exponent, and it also has a 1/2 exponent. Even if it had just one of those, that would make it not a polynomial. 2x squared plus 1/2 x minus 5 is okay because it has a whole number exponent there, and then in fact it has a whole number exponent there. Okay, now you can see this is a polynomial. Just to kind of clarify that again, it has a term, which the first term is written is 2x squared, plus another term, which is 1/2 to the x, and then it actually does have another term added to that, but that last term is a negative 5. So this is a polynomial since, again, positive or whole number exponents and the sum of some different terms. What is a monomial? This is the second thing we're going to define. A monomial is a single term. So mono means one. If you've ever heard the phrase mano y mano, it means like you versus me or one versus one. Mono means one. So it's a single term. It contains a number part and a variable part. So in this first example, it's easy to see those two pieces. We have the number part, which is 3, and then we have the variable part, which is x. So the monomial is something that we've seen before, 3x. I just rewrote it again so my circles didn't get confusing. Here's another monomial. It has a number part and a variable part. Now what will look a little bit different is the variable part actually has 2 variables in it, and the number part isn't written. But remember, if it's not written and it's in front, it means it's multiplying by 1. Last example here, which is the one that people always forget about, is negative 2 is also known as a monomial. It's pretty clear that the number part is negative 2, but what's that variable part? Well, if I imagine a variable there, which I like x personally, since there are no x's, x is technically raised to the 0 power because anything to the 0 power is 1. So if it doesn't have a variable part, it's just hiding because you don't have to write it. So monomials are singular terms. So again, up here, 2x squared, that would be a monomial. 1/2 x, that is a monomial. Negative 5 is a monomial, but you put them all together and you get polynomials. We can name polynomials based on how many terms or monomials they have added together. I would like for you to copy this table down in your notes so that you have this as a reference, because Pearson will ask you some of these names. So first, here's my first example. We have 4x. This is just a monomial. It's got a number part and a variable part. So this has one term. The name that we give it based on the number of terms is monomial. Okay, next one. This is a polynomial, but it has two terms. The first term is x, and the second term is 7. So you can see there's that plus sign in between. Since this has two terms, we call it a binomial. How many tires are on a bicycle? 2. Okay, so bi, that prefix means 2. I bet you can't guess what comes next. Here we have 5x squared, or negative 5x squared times y. Then we have x squared, and then we have x. So there's three terms that are separated by those addition signs. So this has three terms, so we call it a trinomial. Tri, as a prefix, if you think tricycle, means 3. And the last one I have here is 4x squared, y squared, plus 5x minus 2y plus 6. This has 4 terms. And although it might have a special name at this point after trinomial, we usually just call these polynomials. Poly, the prefix, means many. So what it really means is many terms, and once you get past 3, you just sort of stop counting and you just call them all polynomials. And technically you can call all of these polynomials, we just have more specific names for some of the smaller ones. Next, we're going to talk about this term called degree. This is very important because we're going to do a lot of ordering with this. The degree of a polynomial is the highest exponent. And there's some little tricks that go into this, but if you can find the biggest exponent, that is going to be the degree of the polynomial, and then we'll name it. So here's our first example. First off, this would be a monomial because it is just a single term. Well, if I look here, the only exponent I have is 2, so the degree of this polynomial is 2. This one gets a little trickier. It's still a monomial, one term, but do you see how it has both a 5 and a 7 in it? If you have multiple exponents, in order to find the degree, you have to add them together. So this degree would be 12. Last one, this is a tricky one as well because this is just a number. What it's missing is that variable piece. But remember what we talked about on one of the first slides. If it's missing the variable, that means the exponent is 0. So this is a degree 0 polynomial. Here is a polynomial that has 3 terms, so 1, 2, 3. So now we have to make some judgments here and figure out which one is our degree. The exponent of x is 1. The exponent of this second x is 3. And then 4 doesn't have an x, which means its exponent would be 0. Since these are 3 separate terms, we don't add their exponents together. What we do is we pick out the highest exponent, which here the biggest one is 3, so this is a degree 3 polynomial. Here's our last one. This is a 1, 2, 3, so this is a trinomial again. We're going to look at the degrees in each term, or exponents in each term. So this first term has a 3 and a 4, so when we add those together we get 7. The second one has a degree 1 and 1, so we add those together and we get 2. Third one, we have a 1 and a 3, so we add those together and get 4. So they each have their own degree sum, but what we do to say the degree of the whole polynomial is we pick out the highest of those 3. So the highest is 7, so this is a degree 7 polynomial. We can also name our polynomials based on their degree. So copy this table down in your notes. So our first example, if I were to have just a 7, which again is just a number, but it does have a variable part. Remember that variable would have an exponent of 0. The degree is 0, and we call this a constant. The reason why it's called a constant is because since there's no variable, 7 is always just going to stay 7. It's not going to change, so it is constantly 7. Here's our next example for x. The exponent of x is 1, so it's a degree 1, and we call this a linear. That might sound familiar because if you remember when we've had linear equations, something like this, they're all degree 1 polynomials. The next one, 3x squared plus 2x plus 1, and this is actually the one we are going to be studying a lot. The highest power here, or the degree, is 2. This is called a quadratic. It's kind of annoying because quadratics, quad makes me think 4, which does have some relationship to this polynomial, but generally speaking, 2 doesn't make you think quad, but those are what somebody decided to call them. Next one, we have negative 5x squared y. As a reminder, the degree here is not just based on the 2, but based on the y having a power of 1 as well. So this is a degree 3 polynomial, and we call this a cubic. Our last one is a little bit trickier, but again, we're going to look at the highest power. This is a trinomial. It's a polynomial with 4 terms. The degree of this first one is 4. Degree of the second one is 1. Degree of the third one is 1. And the degree of this last one is 0. So the highest power is 4. So this would be a degree 4 polynomial. And fun fact, we just call this a polynomial of 4th degree. Anything above that, we just basically say 4th degree, 5th degree, 6th degree, etc. They don't have their own special names. The last vocabulary-based word is this thing called standard form. And standard form is like the standard way of writing a polynomial. It's what's traditionally written. It makes our lives a lot easier when we start doing some operations with polynomials. So it's important to know the standard form is when the terms are written in descending order. Descending means the exponents are going down according to the degree. So, in other words, it goes from the biggest degree term all the way down to the smallest degree term. So here is kind of a long example. So we have 7x minus 5 minus x cubed plus 6x to the 4th minus 3x squared. So there are 5 terms in this polynomial. We're going to look at the exponents of each. So we have a 1, the second one has a 0, then we have a 3, a 4, and a 2. What we want to do is write these in descending order. I'm just going to write them up above so I don't forget. So I'm going to start with the one that has the highest exponent, which is 6x to the 4th. Very important here to look at the sign in front of your term, so you make sure if it's positive, you keep it positive, and if it's negative, negative, you write it as a negative. So I'm going to write a positive 6x to the 4th first. My next biggest degree is x to the 3rd, but this has a negative sign in front of it. So I'm now going to write minus x to the 3rd. My next biggest would be the degree 2, and again it has that minus sign in front of it, so I'm going to write minus 3x squared. Getting down to the end here, I have 7x to the 1st, and since 7 doesn't have a negative sign in front of it, I am going to make sure I put a plus sign there, so it's positive. And my last term, which is negative 5x to the 0, I will write that last. But I'm just going to write it as negative 5. You don't have to write the x to the 0. Next example, we'll go a little bit faster through this one. This first term has a degree of 0, second term 3, last term 2. So to write it in descending order, I'm going to write that negative 3x cubed first, since that's my highest exponent, then a positive 6x squared second, and then a positive 7 at the end. So if you can always quickly check over 3, 2, nothing, and you're good. Last example, I have a negative 8y squared, because that has a power of 2. I have a positive 2y, and then I have a negative 3. So my exponents go 2, 1, and then nothing. And as a reminder, just make sure there's pluses and minuses in between each and every term. Starting on this slide, we're going to start getting a little more into mathematical operations. And this should be something that you've heard before, which is the idea of combining like terms. Combining like terms is a way of simplifying a polynomial. So a like term is something that has the same variable and same exponents. So for example, make sure I don't have any examples, x and 2x are like terms. Okay, they both have an x and they both have the same variable. Let's see. Another example of like terms would be like x to the power of 2 and negative 3x to the power of 2. They both have that x to the power of 2, so those are like terms. Would x to the power of 3 and y to the power of 3 be considered like terms? Nope, because they are not the same variable. So they have to have the same variable and the same exponent in order to be like terms. What we're going to do with that is we're going to add the numbers in front of these terms in order to simplify them. So we keep the variable and the exponent the same, but we add the numbers in front. So here is our first example. So first, go through and identify your like terms. So I have a 4x and I have a 2x. Those would be considered like terms because they have the same variable. I have a positive 3x squared and a positive x squared. Those are like terms. 5 doesn't have any like terms because there's no other just plain old normal numbers. So what I'm going to do is I'm going to combine my like terms. I'm going to start with my highest power. So I have 3x squared plus 1x squared. So 3 and 1 give me 4. And then I leave it as x squared. It's kind of like if you were adding 3 apples and 1 apple. They would stay apples. My next one, I have 4x and 2x. So 4 and a positive 2 gives me a positive 6x. And then at the end, because 5 doesn't have any friends, we just write plus 5. Here's a couple more examples that you can try on your own, and I am just going to write the answers really quickly so you can see. Check your answers. Did you get them right? Couple tricky things happen here because we end up seeing some negative signs. So remember, negative signs are like adding negative numbers. And also up in this first example, we have a negative 3x and a positive 3x. Since those are opposites, they actually add to 0x, which you don't have to write in the problem. 0x is just 0, which doesn't change the value. Next, we're going to get into adding our polynomials together. So how do we add polynomials? So up here it says, what is the sum of 4x squared plus 2x minus 3 and 3x squared plus 6? These are both polynomials. The first one is a trinomial, and it's degree 2. And the second one is a binomial, and it is also a degree 2. Technically, you can add any two polynomials together. They don't have to match in their names. Sum means addition. I think horizontally is the more traditional way of adding, so I'm going to start with that. So I'm going to set it up first by saying 4x squared plus 2x minus 3 plus 3x squared plus 6. I like to do it this way because I imagine there being a 1 in front of this parenthesis. What that means is if I were to distribute this, 1 times 3x squared is just 3x squared, and 1 times 6 is just 6. So in all reality, you don't even need these parentheses in this problem because they don't really change the terms. So then from here, I'm just adding like terms. So I have a 4x squared and a positive 3x squared, so that gives me 7x squared. I have 2x, and no other x's, so I just have plus 2x. And then I have my constants, negative 3 and positive 6, which add to positive 3. So that's what I would get if I added those together. Adding vertically is actually kind of a fun method. So we can take 4x squared plus 2x minus 3, and I want to add that other polynomial to it. The one catch on this is you have to make sure you line up your like terms. So I'm going to put my 3x squared underneath my 4x squared, and I'm going to put my positive 6 underneath my negative 3. Then I'm just adding straight down like we did when we did elimination. Negative 3 plus 6 is a positive 3. 2x is adding with nothing, so that's still 2x. And then I have 4x squared plus 3x squared, which gives me 7x squared. Both of them end up giving you the same answer. It's just a matter of how you like to organize your problem. Pick a method you would like to use, whether you want to add horizontally or vertically. Take a couple minutes to try these problems on your own, and then come back and check the answers when you're done. Regardless of the method you chose, you would have gotten the same answer. I would say in the first problem, I, again, probably would prefer the horizontal because the vertical is a little tough to line up if you're not careful. In the second problem, I actually really like the vertical method because it's nice and easy to line up the terms underneath each other. So it's very dependent upon what you prefer, and both will get you the right answer. You probably guessed this was coming, but we are going to get into subtracting polynomials next. So in this first example, it says, what is the difference? Difference means subtraction. We have a trinomial, and then we are subtracting another trinomial. Subtracting is always more difficult than adding, just because you have to worry about changing some signs. So again, I'm going to start horizontally because that's the more traditional method. So we have 6x squared plus 3x minus 2, and I am subtracting 3x squared plus 5x minus 8. Now you might remember when we were adding, we talked about the fact that there's this imaginary 1 in front of that second polynomial. Well, in this case, when we distribute a negative 1, it does end up changing the signs of that second polynomial. So my first one stays the same, but now I'm going to get a negative 3x squared, a negative 5x, and a positive 8. Now notice the signs just switched because I'm not multiplying them by like 2 or 5 or 10, I'm multiplying by 1, but because of the negative, it changes those signs. Once you get it to this place, you're in the same place you were before, which is combining like terms. So I have a 6x squared and a minus 3x squared, and that gives me 3x squared. I have a 3x and a negative 5x. 3 and negative 5 is negative 2x. And then lastly, I have a negative 2 and a positive 8. Negative 2 plus 8 is positive 6. If you would prefer, because you like the vertical method, you can also line these up. We have 6x squared plus 3x minus 2. And here I am subtracting 3x squared plus 5x minus 8. The harder part about this is the fact that you have to remember to go back to this subtraction sign every single time. So instead for me, instead of subtracting, I like to think about adding the opposite of all of my second terms, or my second polynomial. Once you get that, and that's essentially like distributing a negative, you're combining like terms within your rows. So we get the same answer, 3x squared. 3 and negative 5 gives us negative 2x and a positive 6. It's just aligned a little differently. So in both of these cases, you have to remember to change the sign or distribute the negative. Try these two examples on your own, and again, stop the video and see if you can do them independently, and then come back and check your answers. As you're looking through your work, just make sure that you distributed the negative in both of these. In the second example, I think doing it horizontally, this first way, is a little simpler because the setup vertically is kind of weird. In the first problem, I think either way is great, and in fact, the vertical method is actually pretty slick because they line up really nicely. So again, there's not a right or wrong way, just make sure you're distributing your negative and combining like terms properly. One other thing I want to mention in this second problem, you might have gotten a slightly different answer than me, only because maybe you didn't put it in standard form. As a reminder, we are always going to try to put our polynomials in order of their degree. So mine goes 2, 1, 0. So make sure you're getting good practice at writing those in the order that they should be in. This last example is a word problem or an application problem. It's dealing with the area of solar panels, and they give us the total areas for the large solar panels, the small solar panels, and the medium solar panels. And what they want to do is have us figure out how much total area is taken up. If we want to find the total, what we need to do is add each of our polynomials together. So 32x squared plus 384x plus 4x squared plus 24x plus 33x squared plus 272x, getting a little squishy there. Since we're adding, it doesn't really matter if I have those parentheses there or not, but what we're looking for is combining like terms. So I have 32x squared, 4x squared, and 33x squared. That gives me 69x squareds. Then we have 384x, 24x, and 272x, which when I add those together, I get 480x. This would be a simplified expression that represents the area of all of the solar panels put together. Pause this video if you'd like to take a look over the concept summary. We talked about standard form, we talked about naming our polynomials by degree and how many terms are in there, and then we talked about adding and subtracting polynomials. You have some practice problems to work on, which are on Pearson and also on a worksheet that you could do from the textbook. I would hope that you would do this practice over the weekend so that we can come back on Monday and clarify any questions you might have in order to take the lesson quiz. Good luck!